Welcome back to PPD. Now we are in the last stages of Relational Algebra Basic series. Here now we are learning about compound operators. We learned about compound operator intersection in the last video, and now we are going to focus on compound operator join, and especially we are going to focus on natural join. So in this video, we are going to focus on compound operator join. So let's start with the definition and the normal syntax that we use for our compound operator join. Join. Join is actually related with cross product, selection, and sometimes projection. Okay. Whenever we are doing a join operation on two relations, it includes three basic operations. What are they? Cross product, selection, and sometimes projection. And how can we define this? Well, join combines tuples in relation by using cross product operation with a selection condition. Sometimes it might also have projection, sometimes a projection. And why do we use projection? To simplify the result. We know that cross product is a little bit confusing operation. Why? It combines every single tuple in one relation and pairs it with every single tuple in another relation, which means common attributes may repeat. Common attributes may repeat. I have already told you about that in the cross product explanation. Yeah. For example, let's say if there is a cross product in between employee relation and staff relation, we know that emp id will be an a common attribute for these two relations. Yeah. So when this happens, there will be duplicate attributes sometimes. So to avoid that, we are going to use the projection in join. Okay. We are going to use projection in the join compound operation. And this can be simply understood as linking tuples, linking related tuples, linking related tuples with common attributes, common attributes based on specific condition, based on specific condition. This is what we call join. And the most common join that we use is natural join. The most common join that we use is natural join. And natural join as a notation which looks like a Thor hammer. Looks like a Thor hammer. And I don't know why it looks like a Thor hammer to me. If it does, yeah, I'm happy for you. So let's start natural join. Natural join. Natural join is a type of join. Okay, natural join is a type of join. If we have common attributes or common columns in two relations, if they have equal values in each of them, If the column attributes in two relations have equal values, natural join is used to isolate the tuples which have uh, the common attributes with the equal values. Okay, so it combine tuples with common attributes where the values are equal in both relations. So we obviously need two relations to perform natural join, and that's pretty much already we assume that. Yeah, when we are talking about joining, you can't join the same relation. Yeah, you can't join the same relation. Well, you can do that, but here we are talking about two relational instances. That's very important. So we'll now look at what happens when you give the syntax of natural join, when you give the syntax of natural join. So the syntax is R1 natural join with R2. This has three main steps. The first thing is R1 cross product R2. There will be cross product between R1 and R2. Okay, R1 and R2 will be going through the operation called cross product. And the second step will be the selection step. The second step will be the selection step. Here, the condition is the values of attributes appearing in both relations must be equal. The common attributes must have equal values. Here, the selection is what? Selection condition is what? Condition is that the values in common attributes must be equal. That's the selection part. Third and last one, projection. Third and last one, projection. Here, we will only project the unique attributes or unique columns and common columns, but only once. Okay, unique columns and only one copy of the column attribute. One common attribute, one copy of the common attribute. Okay, so this eliminates duplicate attribute. This eliminates duplicate attribute. This is what happens behind natural join. So, what if we were supposed to write using only basic relational algebraic operation, the natural join, by using only basic relational algebraic operations? Well, it can be done. It can be done. Okay, now I'm going to teach you that. Let's say we are performing natural join between R1 and R2. Let's say that's what we are doing. First thing that happens is R1 cross product R2. That's what happens first. That's what happens first. And then we will be selecting tuples with equal values in both relations. Equal values in both relations in the common attributes. Let's say the column 1, okay, in R1, column 4, in R1, column 4 is same as R2, column 6, maybe. They are the common attributes. Well, now we can use the selection here. We can use the selection. The selection condition will be R1 dot column 4 equals R2 dot column 6. This will be the condition. We can't stop here. We also need projection. Why? Even though other columns are unique, column 4 and column 6 may repeat. That's why we need projection. And in projection, what we say is only unique columns, comma, one copy of common column. That's all we need to understand natural join by using only basic relational algebraic operations. That's all we should know. Very simple, very simple. If you know what happens step by step, you can simply perform natural join. There is nothing much to do here. Okay, let's just learn this with an example. Let's say there is a relation R. Okay, there is a relation R which has let's say column A, column B, and column C. Let's say it has column A, column B, column C. And column A is 1, 2, 3, and column B has some random letters A, B, A, C, A, D, and C has some thing about like New York, London, Berlin. Okay, that's it. This is the idea. And let's say there is a relation S with two columns which are A and D. Okay. Now you can see A is the common column here. A is the common column here. Let's say it has only 1, 2. And for D, let's say it has some job job positions. Yeah. Manager, writer, like that. Here, if you perform R natural join S, if you perform R natural join S, the first step will be R into S. So A, B, C, A, D, 1, A, B, New York. Instead of New York, I'm going to say NY. Instead of London, I'm going to say L. Instead of Berlin, I'm going to say D. Instead of manager, I'm going to say capital M, writer W. So A will be 1 and it will be M. 1 AB New York, 2 writer, 2 AC London, 1 manager, 2 AC London. Okay, London looks like 1. So what I'm going to do is I'm going to write like this: 2 AC London, 2 writer, 3 AD Berlin. Okay, B looks good. B 1 manager, 3 AD Berlin 2 writer. This was the first step. This was the first step. And the second step, we know that in the second step, right? The second step, we know we will be performing R1 R dot A is equals to R dot A is equals to S dot A. The selection will be R dot A is equals to S dot A. So since we are performing this now, we will be looking at only the equal values. So A1 A1 irunda, here also A should be 1. If A is 2 here, here also A should be 2. Well, then this is not the answer. Okay, A2, 2. But since we don't have A3, A3, only these two tuples are selected. Only these two tuples are selected. A, B, C, A, B, 1 AB New York, 1 manager, 2 AC L, 2 writer. And final one, we have projection, which says we need A, B, C, and D. None other than that. None other than that. R into S. Here, sigma R dot A is equals to S dot A R into. And now the output will be ABCD, 1 AB New York manager, 2 AC London writer. So this is natural join. This is natural join. Here let's see a practical example. Let's see a practical example. There are two relation R and S, and for each relation we have for relation R we have employee ID, name, department, department manager in relation S. So what happens when we apply R natural join S? First of all, R into S. Then selection, we need to select R dot department. R dot department is equals to S dot department. This will be the selection from R cross product S. Finally, we will project only important ones, which are employee ID. We have to mention which column we are using, right? Or else, actually, no. You can actually use employee ID, uh, name, department, manager, and inside this bracket will be this. Shall we look at the steps one by one with the tables? So cross product happens, cross product is done. We know obviously in the selection process, some of the tuples are going to get cut. These one will be getting cut. Why? The department are not equal. They are not equal values. Only for these three, we have equal values. And we know after the projection, one of this column will be removed. So finally, we will be left with one LS HR Sara like that. Shall we look at that? So this is the final output. After selection, we have the projection. So this is how we do natural join.
Thank you for watching this detailed guide on natural join in relational algebra. If you enjoyed the video, please like the video, show your support, share it with friends and classmates, subscribe to the channel, and turn on notifications for more updates on the Relational Algebra series and other ICT lessons. I'll see you in the next video. Until then, keep learning and stay curious. Bye bye.